Hey folks, in this session, let us take a quick look at a demo video of how functions are written in Solidity. We have already taken a quick look at what are functions. Now let's see them in action. So I'm going to open up my Remix editor so that I can write a very small contract for functions. So I already have created a contract called functions lab, which I'm going to just use functionslab.sol, where I'm just going to demonstrate a couple of functions, right? So I'm just going to create a variable called a, which is an address variable called b, an integer and an address variable, just to show you some manipulations, right? So here is how do we start writing the function first, right? So to start writing a function, we need to use a keyword called function keyword followed by the name of the function, right? So I'm going to say some function. Let me have another variable b, right? And then I can give open and closed brackets within which I need to specify the arguments that I will be sending to this function. So for example, I'm going to create a sum. So I'm going to send an argument underscore a and I'm going to send another argument underscore b. These are the arguments that are going to be accessible inside the function. After I create the argument list, I need to give the access specifier of this function. I can choose to keep this function public, private, external, or internal. I'm going to choose to keep it public for now. Post this, I can also mention whether it is a view function or a pure function. But within this function, I am going to access the variables within the contract, that is A and B. So it's going to be neither view nor pure. So now for every function, you can return a variable from the function or a group of variables, right? In order to return, we need to use a keyword called returns. So I'm going to write returns and then I'm going to return another variable C, which is going to be the sum of A and B. Now, in this function, I obviously can access A and B, and I'm going to assign the arguments that I sent to these variables. So I'm going to say A is equal to underscore A, B is equal to underscore B, and then I'm going to say create a new variable underscore C is equal to, or I can just say C is equal to A plus B, right? And then here I can say return C. Now here, there is an error that this declaration shadows an existing declaration. Why? Because I have mentioned or I have already mentioned in the returns that I need to return C. Now here is where you can try a different type of return where you can omit the variable name that you want to return and only keep the data type. Once I do that and save it, you can see that return C would automatically associate with the uint and the sum of A plus B can be returned, right? Now I can also say uint C and try to change the name of this, or I can just say return A plus B. So now A plus B is nothing but C because I've already named the variable here. I can directly return A plus B. Now, if I want to pass some ether to this function and make this function payable, I can use the keyword payable after the access specifier like this. So I can say that this function is payable by using the keyword payable over here. There is another type of function called constructor, which is called when a particular contract is deployed for the first ever time. Constructor is the first ever entry point into a contract. The constructor can also take arguments and you can set the initial value of a particular variable using constructor. For example, I can set the initial values for A and B using. So, as I was saying, I can set the value of these variables that are a part of my contract within a constructor. Whenever we deploy a contract, a constructor will be the first ever function or the entry point to that contract. So you can see that I've set a is equal to underscore a and b is equal to underscore b. Now, if I want to use these variables directly and not pass any arguments, I can just remove this whole piece of code and just say return a plus b because I'm already initializing the value of a and b while calling the constructor. Now let us try and deploy this contract and also do a little bit of testing. So I've compiled this. There's already a green tick here. There's a Now you can see that while deploying the contract, because there is a constructor, it asks me to give an initial value for A and B. So I'm going to say that A is 5 and B is 5, and I'm going to deploy this contract. You can see that the contract is deployed. If I call the sum function now, because it is a public function, I can call it and I can get the value of it. It is supposed to return a value. So let us go here and see that the value of C, which is the parameter, return parameter, is 10, right? Now, let us see what happens if this function is made private, okay? All right, so it says that this is an error because the private and internal functions cannot be payable. Well, that makes sense. Why? Because the payment for a contract comes from an external account, right? And here, if it is private, it can't be paid. It can't be made payable. So I'm going to remove this and have the private tag. It says that functions mutability can be restricted to view. Why does it tell me that? Because here I'm not manipulating any state variable, right? I'm just reading the value of the state variable. I'm adding them and I'm sending them in the form of another variable called C. I'm actually not changing the value of either A or B. So it's a view function. Let's make it view. Now let's save our contract. Let's delete the old one. Let's compile again. I think it has auto compiled. And I'm going to again deploy this. Now I have deployed this contract, but you see, I don't have access to this function because it is not public. It is a private function. So another function inside the contract is only able to call this function. So let's quickly write another function. I'm just going to call it another function. Oops. I don't need any parameters and I'm going to make this one public, or let's try external. So, and then say returns uint. I'm going to say uint d is equal to some function. I'm going to say return d. Yeah. Now again, this is view only because we are not changing anything here, right? So I have to add the variable view, sorry, keyword view. Now the contract is already compiled. Let's deploy it with 10 and 10. Transact. Delete older one. Oops, sorry, let me deploy again. Here is another function. If I call another function, it gives me that the answer is 20 because 10 plus 10, 20, right? So because this is private, now this is external. What that means is I can call this function externally, but I can't call this internally, right? So if we change it to internal, then it can only be called internally. So these are the different types of functions that are available in Solidity. I would highly recommend to explore and do a lab on this so you get a deeper understanding of how functions work. Thank you, and I'll see you in the next session.